everyone. My research is focused on the IC design and for different topics, the sensors, I/O, and power management. Okay, then I would like to introduce myself first. I graduated in NSYSU as well, and now I'm doing for the research focused on the IC design in those different areas. I will introduce later. And I win some honors of the best paper award and excellent teaching award in recently. But this slide I would like to show you what is IC design. So this is the IC design flow. We call it full custom design flow. So firstly, you will get some idea, and then we would start to design the circuit like this. We design the circuit on the computer, okay, and you can put some components on the screen and start do some wire circuit, wire connection, and then we can run the simulation with the HSpice so that you can see some waveform. And if you check that the waveform is correct, then we can start to draw the layout. This is the actually structure on the IC on the silicon. So then if we complete the layout, we ensure that the waveform is correct, we can send the layout file to the foundry like TSMC. Then they will design the chip, the real chip for us. Then we can get the chip back. So this is the photo of the chip, and then we can use the chip to do the measurement so that you can see the waveform on those equipment, and the waveform will be the same with what you see on the computer. So that's what we do. Okay, so this photo is a wafer that you can see in the foundry, but we really don't touch that wafer because our major mission is almost in front of the computer. But we can use our knowledge to design the chip and complete the file, and the foundry will develop the chip for us. Okay, so this slide shows you some circuits that we designed in our lab. So this is a temperature sensor. So we use some small FET and to construct this circuit. And the basic idea is use the OP amplifier with the negative feedback. And with the negative feedback, we can get some benefits. So the output will be stable and the performance will be good. So you can see here, the output is the linearity is good and the error is very small. And this is the measurement result. So you see here, we can have the diphoto and we do the measurement. This is the measurement waveform, and the performance is good. Okay, then I would like to give you another example. This is a LDO regulator. Its mission is to generate a stable output here for providing the power for another circuit on the chip. So we can see here, this is the output. This is the change of the load current, because when we use the equipment, it will consume some current. So when the current changes, the output is still very stable. You check here, it's 1.7 millivolt to 1.8. So the variation is very small, and the output efficiency is more than 99%.
Wow.
So the performance is good. And then this is another topic that developed in our lab. It's the high-speed I/O buffers. So this here is the circuits, and we use some compensation for the power process, voltage, and temperature detector. So when we detect those variation, and then we can use that to compensate the performance of the circuit. So this is the measurement result, the eye diagram. So the eye diagram from different chip and different temperature is all meet our requirements. So the performance is very good. And besides, the frequency is up to 3.2 gigabit per second with very, very low operating voltage, which is only 0.3 volt. And this another topic in the also popular topic is ADC design, analog to digital converter. So the simulation result, we can get more than 9 ENOB. That means the resolution is more than 9 bits. and with the sampling rate of 72 mega sampling per second. So this is the simulation result. The SFDR is good. And this is the final research topic in our lab. This is a gate driver with the gallium nitride process. The gallium nitride is a new technology for the high power, high voltage application. So in our design, we use this process to design the circuits. So it can operate at a very high voltage, 25 volts, and the efficiency is 98.9%. So here are some waveform that we get from the simulation stage. All right, so in my lab now I have 16 Taiwan students, and one student graduated my lab, which is from India, and right now he's working in Taiwan. Micron Technology is a IT design company, so now he's working in Taiwan. And here is the website of my lab, or you can Google in NSYSU to reach me in a double department. And here's the equipment in my lab. We have those equipment for measuring our chip, like a power supply, oscilloscope, and here the circuit we design. And for a further advanced measurement, like a temperature chamber, we will go to TSRI. Is a unit in Taiwan. It providing some equipment for us, so that we can do the measurement, advanced measurement there. And this slide shows you some photos in our lab. The student will present in the international conference, and we will still have some social events in our lab, and the student will attend some contests and win some honors. So here are some honors of the students. They attend the conference and present their idea and their work, so they will win some paper award. All right, and this slide shows you that another benefit to study in Taiwan, because in Taiwan we have several IC design house and a foundry. So some of them are the top 3 in around the world. So here, MediaTek, Realtek, Novatech, they are all from Taiwan, and the most famous foundry, TSMC, is also in Taiwan. So here, this is another benefit that you study in Taiwan. You may have the chance to get a job in Taiwan. Okay, and this is the slide show you that the requirement in our lab for the master student and PhD students. In our lab, the students have to complete the educational chip for 1 and 2 advanced chip, or 1 advanced chip and 1 conference paper, or 2 conference papers. So usually my students graduate will get a 2 advanced chip. The advanced chip then means that you have to have some something new in your idea of your idea, and then you need to pass some under some serious review, so that you can pass and you can get the advanced chip. But for PhD students, they will learn how to become a project leader, and they will also learn how to write the paper and communicate with other group, other professors. All right, so we are looking for the students. If you're interested in IC design, you have some creativity, positivity, and self-demanding, highly stress resistance, and you can have a good guys in the teamwork. We welcome you to join us. Thank you.
Thank you, Professor Lee, for such a informative presentation.